left off part 1 of this lesson with this diagram. All we really did was organize data that represented 2 different variables into a table. So just as a quick refresher, we have either your male or female, either you want an SUV or a sports car, and then each of these numbers were called joint frequencies because they represented the frequency of a person fitting 2 categories, joint categories, right? A man who likes an SUV, a man who likes a sports car, a woman who likes an SUV, a woman who likes a sports car. We then had our marginal frequencies, right? The chance of just one of those variables being true. So the chance of someone just liking an SUV or just liking a sports car, a chance of someone just being a woman or just being a man in this group. What we're going to look at today is a way to kind of even out our data so that our numbers actually mean something in relation to the whole number of people that we've looked at. So when you're looking for a relative frequency, a frequency that's relative to the whole table, we have to consider this number right here. And this number didn't really get too much love in our last lesson, but it's really important because this represents how many people you've actually interviewed or surveyed. This number can help us even out our data and give us numbers that really show us what percentage of people fall into each of these categories. Percentages are so helpful because we in our base 10 math system, meaning like we tend to think in tens and hundreds and thousands, percent just means per hundred. And it gives our brain a really easy way to think about numbers. For instance, me saying that 21 out of 240 people are men who like SUVs may give you a fuzzy idea of what I'm saying, but it's so much more powerful to say 9% of all these people were men who liked SUVs. In the same way, saying something like 45 out of 240, can you see that? Yeah. 45 out of 240 people were women who like sports cars is an okay statement. Like it helps you understand something, but it's so much more powerful to say 19% of people were women who liked SUVs. So we're going to work on how to do that. So here we have each of the values that we originally had. And what we're going to do to show what percentage of all the people we have in each of these cells is we're simply going to divide by that whole. We're going to look at that number, 240, and take each of these numbers, just as I was doing before, and put them in the denominator of a fraction. So instead of 21 here, I get 21 over 240. So really all you would have to do is take your calculator and do 21 divided by 240. And once you plug that in, you would get 0.09. Now in our last unit, we focused a lot on converting decimals to percentages, so this should be easy now. To convert this to a percentage, we multiply by 100, and we get that this is 9%. In our table, we're actually going to leave it in decimal form. For our own understanding, it's helpful to see that just because we can instantly know what percentage that is. So in our table, I'm just going to put this equals 0.09. And you and I know that means 9%. We'll now do the exact same thing for each of the other values in this table. And when we're done with that, what we're going to have are a lot of numbers that actually add up to the number 1. That's because once we actually take this total, right, and divide it by the total, 240 over 240, we would get the number 1, right? The total of all these things that we're going to have in here add up to 1, which, as you know from our last unit, is representative of 100%. So I'm just going to quickly do that for each of them. I would encourage you to do a few on your own with your calculator just so you see how it works, but it's not necessary to go through every single one of them. Once we've done all of that math, we get some really interesting information. One of the first things that stands out to me is when I look at this is that under the totals of male and female, we see that males only make up 25% of the responders, whereas females make up 75% of the responders. So that gives us this idea that even if we look at the answer totals and see, okay, well, 39 men like sports cars and 45 women like sports cars, that doesn't mean that women in general like sports cars more. It just means that more women answered. We're going to see when we calculate relative frequencies for rows and for columns, there's going to be a lot of math involved here, a lot of calculation involved rather, I'd say. So I want you to listen more to the ideas of what's happening and get less caught up in the calculation side, because that is something that you can easily learn to do with a calculator. This was what we call relative frequency for the whole table, frequency relative to the entire thing. That's why we were dividing by the number 240. That number was really important to us because it represented the whole, or what we were considering the whole. So if we wanted to calculate the relative frequency for rows, what we would be doing would be within each row, we would be considering the total amount of men and women as like the whole. That's what we would put into our denominators. Let me show you what that would look like for the male row. Instead of dividing this by 240, I would be considering 60 to be the total number of responders, just for this row. Of course, that would mean our total here would equal 1. This would be like our 100%. And then we'd go row by row, and instead of dividing by the total number overall, we would divide by the total number of males, because that's who's responding in this row. So here we get 0.65, and here we would get 0.35. What this does for us is it gives us an idea of within this category, within this variable, how was the other set of variables split? So we can actually say, okay, 35% of the male responders wanted SUVs, and 65% of the male responders wanted sports cars. If we wanted to do the same thing for the female row, we would not divide by 60. We would divide by the total number of female responders, which was 180. Let's do it for that row. All right, let's take a look at the female row. From this calculation, we can see that 75% of female responders wanted an SUV and 25% of female responders wanted a sports car. We actually see that proportionally less women wanted sports cars than men. We would leave this last row the same just because the total of that row is 240, and so we'd be dividing by 240 both times there. So this shows us, if we do this by row instead of for the overall table, what this shows us is how the genders were split. It shows us among all men how many wanted SUV and how many wanted sports car. Among all women, how many wanted SUV, how many wanted sports car. The other way we can organize this data is by column totals. So if we wanted to calculate the relative frequency for columns, the question we'd be answering would be, okay, among people who like SUVs, how many were men, how many were women? And then among people who like sports cars, how many were men and how many were women? So let's consider what total we'd be using for our first column of SUVs. We'd actually be looking at this number right there because overall 156 people said that they wanted SUVs. So this would become, down here, our 100%. I do 156 divided by 156 and get 1.0. I'd divide this by 156 and I would get 0.87. And finally, I would divide this by 156 and I would get 0.13. Okay, so what this is showing us is that among the people who liked SUVs, 87% of them were women and 13% of them were men. Let's do the same for each of the other columns. In this column, I'm going to use a total of 84 because that's how many people overall said they like sports cars. All right, we've organized it by column, which means we've used the totals of each column as our whole when we do our division. As you can see, we already talked about the SUV column, but in the sports car column, we get a little bit of misleading data. This data is not great to represent on its own Because what it's saying is 46% of the sports car people were men and 54% were women. And if you just heard that statistic, you would think, okay, more women than men like sports cars. But the next column helps us out here because it shows us that of all the people, only 25% were men and 75% were women. So you see, sometimes statistics can be used to be really misleading. Like if you only talked about this column, that would be some really, really misleading data, even though it would technically be true. They would have just forgotten to mention the fact that they interviewed way more women than men. It was a lot of information to process. If you're still confused, I would suggest just rewatching the video a few more times, making sure your notes are really solid. But again, I will always be there to answer questions if you want to comment and ask a question, if you want to email me and ask a question, or if you want to ask one in class.